Today, we are looking at ratios and understanding the concepts of ratios and equivalent ratios. We have talked about how a ratio is a comparison of two quantities. We can have part to part to whole, or whole to part ratios. When we write ratios, the order does matter, the way that we write that. And then there are two ways we can write that. We can use the colon or we can use the word to. So here we have a collection of coins. If we write the ratios, this first one is asking us to write the ratio of pennies to quarters. So we would go in that order, pennies to quarters. So if we look over here, there are 6 pennies, there are 7 quarters. So we would write 6 to 7 or 6 to 7 this way. The next one asks us to compare quarters to dimes. So again, we always go in that order. And if I look over here, there are 7 quarters, there are 3 dimes. So 7 to 3, or you could write 7 to 3. The last one is ratio of dimes to the total number of coins. So there are 3 dimes. You can count all the coins or add what we have here, and it comes up to 16. So I would have 3 to 16 or 3 to 16 this way. Okay, go ahead and pause your video and write the ratio for numbers 1 and 2. Okay, dimes to pennies, 3 to 6. And then quarters, the total number was 7 to 16. Okay, so that's writing ratios. There are 2 different ways to do that. The next thing we're going to look at is identifying what's called the value of the ratio. So when we write the value of the ratio, we write it as a fraction, so A over B, and that would be compared to the ratio written this way with the colon or the word to. Okay, so when we write the value of a ratio, we'll look at a couple of examples here. This first one says the ratio of rubies to diamonds on a ring is 1 to 2. We're going to find and interpret the value of the ratio. So the value of the ratio itself is just that ratio written as a fraction. So we would say that the value is 1/2. That is the value of this ratio. The ratio is 1 to 2. The value is 1 over 2 or 1/2. And when we interpret the ratio, we look at what we have here, the ratio of rubies to diamonds. So in that order, 1 ruby to 2 diamonds. So we would say the number of rubies is half the number of diamonds. The number of rubies is 1/2 the number of diamonds. Okay, on the next one, another ring, the number of rubies is 4 times the number of diamonds. So the number of rubies is 4 times the number of diamonds. So there's our ratio relationship. We're going to write the ratio of rubies to diamonds. So if there are 4 times as many rubies as diamonds, the ratio of rubies to diamonds is 4 to 1. There's 4 rubies for every 1 diamond, for each diamond. Okay, you're going to pause your video now and go ahead and try number 3. An elephant sanctuary contains adult and baby elephants. The ratio of adult elephants to baby elephants is 5 to 1. So there is your ratio. Okay. Find and interpret the value of the ratio. What is the value? And then what does that mean? This means the number of adult elephants is 5 times the number of baby elephants because the value is 5. All right, go ahead and turn the page. Okay, the last thing we're going to look at today is equivalent ratios. So when we have 2 ratios that describe the same relationship, they are equivalent ratios. It is very, very similar to fractions. If I have, for instance, 1 to 3 and 2 to 6, if I set them up this way, 1 to 3 and 2 to 6, I can multiply them both by 2, both digits in the ratio, to get the next one. You can see that in fraction form as well. If we write the value of the ratio, they are equivalent fractions. So if we determine if a ratio is equivalent, similar process to working with fractions. Here I have 4 to 3 and 20 to 15. So if I set it up this way, here's 4 to 3, and here's 20 to 15. If I set it up like this, okay, I can see here that if I go to get from 4 to 20, I would do 4 times 5. And then to get from 3 to 15, I would also go 3 times 5. So since I would multiply them by the same thing, we would say that yes, these are equivalent. Similarly, we could show that as a fraction. Okay, if you prefer to see it as a fraction, 4/3 equals 20/15. Okay, let's try that with letter B, 5 to 7 and 10 to 21. So again, if I set this up, 5 to 7, 10 to 21. Okay, if we look at this, 5 times 2 is 10, but 7 times 3 is 21. I did not multiply them by the same number, therefore they are not equivalent. Okay, pause your video and then look at 4, 5, and 6, and you're just going to determine whether the ratios are equivalent or not equivalent. So you can show it this way, what you're multiplying by. If you prefer to see them, write them as a value, two fractions, and show it that way, you can do it that way as well. Okay, go ahead and check. The first one was equivalent. 5 and 6 were not equivalent. All right, the last one we're going to look at here. Meg is speed walking at a pace of 5 meters for every 2 seconds. Sean's pace is 10 meters every 5 seconds. So the question we're going to answer, put a box around that, are they speed walking at the same pace? And if not, who is faster? So let's take a look at each one. We have Meg. Meg's pace is 5 to 2. 5 meters every 2 seconds. Sean's pace, 10 meters every 5 seconds. So we're going to look and see, are these equivalent? 5 times 2 is 10, but 2 times 2 is not 5. So these are not equivalent. So since they're not equivalent, that means they are not walking at the same pace. So if we want to figure out who is faster, we need to make something the same here. So what we can do is we can take Meg's 5 meters and turn it into 10 meters. So Sean, 10 meters every 5 seconds. If we take Meg and we take her 5 to 2, okay, and we turn it into 10, we're going to figure out how many meters is, or how many seconds does it take Meg to walk 10 meters? So 5 times 2 is 10. So I'm going to do 2 times 2 to get 4. Times 2. Okay, so now we can look at this. Okay, when Sean walks 10 meters, it takes him 5 seconds. When Meg walks 10 meters, it takes her 4 seconds. So they're not walking at the same pace. We would say no, and Meg is faster because when they both walk 10 meters, Meg gets the 10 meters in 4 seconds, Sean gets the 10 meters in 5 seconds. All right, and then you're going to pause your video and try number 7 and 8. The ratio of wolves to cougars in a forest is 5 to 3. Find and interpret the value. And then number 8 is similar to Meg and Sean up here. Okay, so number 7, the value is 5/3 because my ratio is 5 to 3. That means the number of wolves is 5/3 the number of cougars. Number 8, you were kayaking at a pace of 63 feet every 12 seconds. Your friend's pace is 21 feet every 3 seconds. Okay, those are not equivalent, so you are not kayaking at the same pace. You need to figure out who is faster. So I did this so that both ratios have 12 seconds. So in 12 seconds, you went 63 feet. In 12 seconds, your friend went 84 feet. So, no, you are not kayaking at the same pace. Your friend is faster.